very important for me. So please have a big round of applause for our friend Iulia Feroli. Hopefully I said that correctly.
Thank you. Thank you.
Thank you very much, Iulia, for joining us.
Thank you
How are you
for
feeling?
having me. Good. That was an awesome talk.
Anxiety, stress, feeling all right?
Yeah, just excited. It's all good.
Excitement, that's good. That's the good feeling. Okay. So, are you set? Do you need any help? No, apparently it's all good.
I'm good.
So.
Well, I think we have 15 minutes.
Oh, no, we can go
Yeah,
ahead.
it's a
We
bit
can
early.
go?
Yeah.
Oh, okay.
Okay, ahead of schedule. Great.
The stage is yours.
Thank you. All right. Hello, everyone. Great to see you. Super nice to be here. One of the prettiest cities I've spoken in so far, so that's great. Again, that was a really awesome talk before, and I related with it a lot because I'm also like a bit early in the career process. I graduated a few years ago, but still like I'm new to the whole dev world, and I've tried a few different sides of tech before. I've worked as an architect for Microsoft. I've worked as a sales engineer. I even did a few months of product marketing manager, making videos about tech content, but the further away I got from actual developing, I wasn't so happy. So I'm really, really glad to be in like the proper ecosystem where all the devs and the engineers are. And I started at Elastic in August last year. I'm a developer advocate, which is a new role for me and something I didn't really know existed before. But basically, we get to go around, in my case, EMEA, and like make presentations about cool demos and tell people how stuff works. So I really love it. And we get a lot of freedom, which is why I'm making my talks about Harry Potter a lot of the times, just because I think it's like a really cool topic and it really helps people to relate to the demo itself. So whenever you create applications and you're trying to demonstrate, especially with natural language, that things works or that it makes sense, it's a lot easier when people know the domain, so then they can kind of understand if it makes sense or not. So that's one reason that I use Harry Potter. Another reason is that it's just books are really, really good resources in terms of data when you want to work with text. It makes people think about it differently. Normally, when you say data, you think of a table with columns and features, but these are just pages. So I think the idea of trying to push that forward of how do you take pages and create models out of it is really cool. One thing I used to always describe is how translation models work, for example. So how like Google Translate or whatever works to translate your sentences. They don't actually understand how languages work, like the grammar or anything like that, but they just have a lot of examples. So I've read the Harry Potter books in English and in Romanian multiple times. And even if you don't know Romanian, if you look at the first page, if you're familiar with the books, you can probably tell like what's on that first page, or even like pretend that you know Romanian. If, like me, you can kind of recite the book from memory. Basically, that's how translation models work as well. They have a lot of examples next to each other, and they're told, okay, this is equivalent to this, and then they can bring that back when you ask, how do I say house? They'll look at when house was mentioned in both sources. So that's like a cool example of how semantic models work, and we'll call back a lot to that in the demo. Another reason I think Harry Potter is really good for this, especially for talking about semantic search and generative AI these days, is because, I don't know if you remember this, but around 2017, when like the hype of embedding and vectors began, this example came out, which was someone created a new Harry Potter book based on the previous books and like just generated a new one. And it was pretty random. It was called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. And it didn't really make sense. It kind of has the style of J.K. Rowling in the way that the sentences go, but it's mostly nonsense. And that's kind of because it was at the very beginning of Gen AI, but it was really, really impressive back then. If you're familiar with ChatGPT and stuff these days, of course, it might look a little less cool because you've seen the things that it can do now. But back in 2017, this was like groundbreaking. And it's kind of like the first example I saw of generative AI and how you can take something someone's familiar with and make it into a whole new thing. So then I thought, let's take the books again and use some of the methods that we have today and see how those perform, and it will hopefully make a bit more sense than that. Now, the second part of the talk was called and the Elastic Python clients. And yes, clients, because we have multiple. First, is anyone here familiar with Elastic? Maybe raise your hand so I know how much to explain. OK, cool. I'll give an introduction then. So Elastic is a search analytics, I think we say it now, but most people know it as a search engine in terms of Elasticsearch. There's like analytics, like Kibana, and there's security elements to it as well. But what most people would use within the dev community is the search part. So anytime you want to create a search engine or a search application or look through your data in a smart and optimized way, a lot of people would use Elastic. And then Elastic works based on API calls, but it also has a lot of language clients, so people can use it with different languages, and those are open source. So clients usually means one per language, but in the case of Python, it's a bit of a special situation, which is kind of why I wanted to make this talk. Like I said, I just started last August, and as a Python programmer, I was trying to figure out, okay, why do we have so many clients? How do they work? How do I get started? Like Irene said, it can be a bit tough if you're newer to developing and you just join a project where there's people who have been working with that tech for like 20 years. Then it's a bit intimidating, and it seems like a lot of the documentation, which again, I really enjoyed that she called that out, is made for people who already kind of know how it works. So when I got started and I looked at it, I thought, okay, we can do a bit better with this. So I wanted to make like a talk to explain it, but also I started my very own pull request and contributed to some of the docs to make it a bit clearer as well. But basically, we have the main Python Elastic client, and this one is a high-level client that's just like an abstraction on top of those API calls. So it works based on JSONs. You have a request that you send in with your query and what you want to look for. You send that over to the Elastic server, and the result comes back. And then we have the Elastic DSL client, Elasticsearch DSL. And this one is more Pythonic, if I can call it that way. So basically for people who want it to look like a Python code, like we have classes and we have different kinds of functions, and it's kind of, you could build it on top of the main client, but just make it a bit more verbose. So the first one looks a bit like this. Again, you may be familiar with those JSON queries. If you've used Elastic in any language, that will work the same way. You can send those queries and those JSONs directly, or you can wrap it in a client. So here we just take the whole body as an argument. So yeah, it just looks like an API call with some Python on top, whereas the DSL looks like this. So this is the same request, but you can see that there's no big curly brackets everywhere, and it just looks a bit more like smooth code. So it's more or less a preference of how you want to use it. I personally prefer the high-level client because then you just take those JSONs and you can try them out in different ways as well. Or you can take it and use it with another language. You can take it and adapt it and make it more shareable. But at the same time, this looks better if you want to build like a bigger project, or you want to, make it more consistent with the way that you develop in Python. How I see it is, especially if you work with notebooks, it's a lot easier to just work with the classic client. The DSL is more for building classes and making files, like to give an example of the different ways people work with Python. And I prefer notebooks. So today we're going to show you a few examples of how that works with various notebooks in Python. But that was not all. You thought that was it. Oh, 2 clients, what's the big deal? There's a third Python client, and this one is called Eland, because we're going with the whole moose thing. If you're familiar with the elk stack for Elastic, it's like Elastic, Logstash, and Kibana. It's an elk, so we have an elk mascot. This is another form of moose, so I feel like open source things are funny that way. And this one specifically for data science. It has its own form of data frames, which are similar to pandas, so you could use one or the other. But more importantly, it's the bridge between Elasticsearch and machine learning models. So how it works is we can use this to import models from other sources, usually open source sources, such as Hugging Face, or you can use OpenAI, you can use various types of compatible models, and you can bring them into your search engine. So basically, you have all the good stuff of Elastic, and then you can add some large language models on top through Eland. So because of this, now even developers who normally would use different languages kind of have to use Eland and kind of have to get used to Python. So that's bringing a lot of people into the Python area, because I think a lot of the Elasticsearch users are historically maybe not very Python people. But yeah, this is a big push, and I feel like that's why also we need more documentation and more examples of how to do that. So yeah, the architecture looks a little like this. If you're familiar with Hugging Face, so that's like a really big project where they host a lot of large language models, so people can use them all from one place in the same format with a lot of their own transformers and other things they can do on top. So any data scientist who would try to make a model with large language models would probably be using Hugging Face. So it's like an industry standard in that sense. And what we do is we take those pre-trained models. So again, if you're familiar with machine learning models, the biggest hurdle is training it, because you would need like a lot of data, you would need a lot of compute. It's very expensive, it takes a lot of time. So in a lot of cases, especially with these really large models, it's not really needed because they're so general, right? So you could specialize it a bit to your use case, but it's usually fine to just take it as it is. So then we take it and we deploy it within Elastic, and then you can run inference on it, which means instead of training the model to be good, the model's already fine, and you just ask it, hey, for this sentence, can you give me what your prediction is? So that makes it a lot faster and a lot less expensive for people. So to summarize, before we go into the demo, we have the Harry Potter books because it's really cool text and data. We have a bit of the chaos with the different models, which might make developers want to make sense of it and explain, okay, where does each client fit in and how do I just make it work? And we have LLMs on top because, yeah, why not? They're popular at the moment, and my background's in data science. I actually wrote my thesis on topic detection in text, so I was doing it before it was cool, but, whatever. So let's take a look at how that works. First, we're going to open up our Elastic Cloud. So I'm using the cloud because it's just easier, and again, I'm not a big infrastructure person, and it's a bit more complicated to deploy it on-prem. This just works with whatever I want to make for demos. And this is the homepage of Elastic. You can do a bunch of stuff, but we're going to just jump in and look at our data. I first made a dashboard with our data so we can take a bit of a look at it. We have different data sets, one from Kaggle about Harry Potter characters that's been created, and then I took the entirety of the books and the movie scripts to make the really cool stuff after. But pretty much, yeah, you can take a look at this, and this is kind of a way of searching as well, if you think about it. So if I select, for example, Gryffindor as the house, you see it here as a sort of filter. That is searching. So I think that's what's really interesting to think about, that some people would say, I don't use search applications, but when you're looking through your data, you're literally searching. So ways of getting the data that you're looking for can be really powerful to do with an optimized search engine. So you can, select multiple things that you want to do, and then they show up here. So this is basically how you create a search query, so to say. So you can see you have the name of the feature, house, and the value, in this case Gryffindor, and all those together create a search. And then we end up with like 7 people that fit all those criteria. And this is done in a visual way. Then if we take it to the next level, we have the Discover page, Harry Potter characters. So here we can look at our data, but we can search through it with a different kind of syntax, which again is similar to how we did it in the dashboard, but most people will be maybe more familiar with this. So again, if I say house should be Gryffindor, I get the results, and you also get them highlighted in there. And then you can keep going, and the blood status should be half-blood, 7 hits. So again, this is using different types of query languages to make these searches. You're probably more familiar with something like SQL. It would work the same way. Whenever you're looking for your data, you are searching. But the thing about this is, say I wrote it like this, it no longer works, right? Because it was looking for the exact spelling and the exact capitalization of the letters, and it no longer comes up with a result, which is a little silly. And usually we would want our search to be a bit better than that. So we would want it to be able to take into account this fuzzy element, Or even go further, and instead of half-blood, maybe you say half-wizard because you don't know the exact name, you would still want it to come up with that result. And this is just when we have data that has very clear columns, but what if I just want to write in and search which were the wizards that were not purebloods again? It should still come up with that answer, right? So then we can start making it a little bit more complex. To do that, we can start using the clients. So as I was showing in the slides before, we can create some notebooks and host them in wherever you want to. You connect with Elastic by just putting in your API keys and your cloud IDs, and then you run queries. So this is how one of those JSON queries would look. Actually, let me show it to you in the dev console here. So besides these tools that are more or less just to get an idea of how things work, this is like the core of Elastic. So I would run a query like this, where, can you see it? I can make it a bit bigger. Where you say, I want to search a match for House Gryffindor. So it gets a little bit more complex, and then we come up with a lot of answers and metadata about the number of hits that we get back, the speed in which it came back, and whatnot. But basically then we get the result back, which is this entry in our data set. And in this case, it's Harry Potter himself as the first result. So this is how people would use Elastic. However, when you do it with Python, it's the exact same thing. We make the JSON, we send the request, but then if we clear this out, we're able to process it a little bit, so we only look at the parts that we want to look at. So then we only print the people's names, for example. So from here, you can make it a little bit easier to work with this search engine in whatever language you choose. You can make more complex queries. In this case, if you can kind of read from the JSONs, we have some fields that don't have an exact value, but have more of a description of what a person does. So then I can look within their jobs or skills for anything to do with Quidditch, if we want to find an athlete in there. We can match, again, the house, and we can even use different types of ranges or filters. So any redhead that does sports in Gryffindor and is born after 1980, if you're familiar with the books, this is probably going to be, the Weasleys. So you can see that it can kind of narrow down through it, the more specific you want to get. Then what we can do is, fully create a new index. This was the characters. But what I want to do is I want to take the movie scripts and the books and add those into my index. So the way you do that is you first create a mapping and you say, okay, I want the character name and the sentence that they say in the movie. This is kind of what I expect them to look like, which will help make the data stored in the right way. And then you put it all in, and then you're able to add entire sentences in your data. So each entry will be a line that the person said in the books, which would then allow you to do more interesting searches. So to get back to this, now that we have text in there, let me put it big again, we can start doing NLP stuff. So NLP, natural language processing, the base of Gen AI and ChatGPT and all that cool stuff, it really starts with these classic tasks that you can do on text. You can do sentiment analysis, so see if a text is positive or negative. You can do key phrase extraction, which can help you process your data a little bit better. You can do embeddings, which then allow you to do the semantic search. So instead of looking for wizard, I can look for magic boy, and that should still come up with the same results. So we can bring those in and see how we interact with that. And we can start with sentiment analysis. We have a new notebook for that. Again, we connect with Elastic pretty much the same way, and the way that we bring those models from Hugging Face or wherever we want to bring them in is using Eland, but also using Docker. So you can run this command, and based on the model ID you have in there, so this is the BERT model, for example, which is, again, one of the most popular ones, I can bring it in and add it to my Elastic deployment, and then I can make calls to that. So let's see what that looks like in the dev console. It's a little easier to interact with. So this one is the sentiment analysis model. and I put in, this is a very good demo. So if we run that, it says it's positive. If I say this is a very boring demo, it's negative. And if you want to try anything out, we can do it at the end as well. So basically, you send in just a text field, and it gives you back the score, positive or negative, as well as the probability, like how sure is it that that's the sentiment that it has picked. And we can do this one by one, or to make it more easy, we can basically create a pipeline. Let's make sure it works in here as well. We have the model ID. And we create a pipeline called sentiment, and then I say, okay, take every single data point in my document and add this model inference to it. So then you can add that as an extra field, and then you can use it in your search. So for every single sentence that someone said, I want to analyze if it was positive or negative, and then add that to my index. So then when I search, I can include the sentiment predicted value in there and look for either super positive or super negative sentences. So, for example, these are the first lines of the first script of the Harry Potter movies, and you can kind of see that for each of them, I'm adding a tag of negative or positive. So then when you're doing your search, you can put that as an option. I want the result in the book based on the sentiment. So, for example, the most negative sentences in the whole series, and I added these to the slide so you can read them a bit easier. So this is what came up, and you can see they are quite negative, and you probably wouldn't be able to find these searches in a different way because, yeah, what words would you even look for? And then alternatively, we have the most positive sentences that came up in the books. So these are also, yeah, super, super positive. They had a really high score for that. So it gives you a new dimension of how you can search in a fun way. And while that is cool, by itself, it's not super useful, but what we want to do is what we call hybrid search, where we take the semantic element and we take all the filters and the good stuff that I showed you before and put it all together. For that, we're going to also add embeddings. Anyone here familiar with embeddings and semantic search? Raise your hand. Okay, then I can give a quick briefing. So again, you may have seen this going around online about anything to do with generative AI, anything to do with models that create new language or act like they can speak. They do that because of embeddings and vector search. So you may know vectors from school back in the day. So if you have an axis where you have, your x and y, you can have, this many lines on the x-axis, these many on the y-axis, and that's a vector. Well, the same thing, but times 1,000. You can put these words into a semantic space that has a lot of dimensions. So then you can kind of compare where they are. Let's give you an example, TensorFlow. There's this really cool visualization from TensorFlow that actually, TensorFlow worked. That shows you a bit how it would look like to have all those. There we go. It's really not coming up now. Visualization. Basically, you can see the space that these words would be in. Again, this is still kind of three-dimensional because putting like thousands of embeddings would be a little difficult. But you can kind of see how words would be placed in this space. And then if I look for something like house, then you have different things that are related, like household and greenhouse, and they'll be closer or further away from each other in this embedding space. And that's like the base of how we encode all these sentences into a space where we can then look for the different meaning. So we can look for synonyms, or we can look for words that are related, again, wizard and magic boy, because of this implementation. So to get back to our example, the way we do that is, again, with a model. We're creating different documents in here. So they're taking all the different book sentences. We're getting a new model from the cloud, this time a sentence transformer that allows us to go from words to that fancy embedding space. And then when that runs, again, you just send it a text field and you get back the result. So with the model ID, basically this sentence becomes this really long vector. So instead of x and y, we now have a really large amount of dimensions, and then the computer can decide which of these vectors are closer to each other. So then again, we create a pipeline. We say for every single sentence, besides knowing the sentiment of it, I also want to know where is it in this vector embedding space, so I can then compare them to each other. So we're running all of that, and then we should be able to get the results, and we can run different searches. So I have a few examples here. If you want to try different ones, we can. I think this is from the previous demo, actually. Let's say this is magic spell, whatever. And for each of these, we would then run the semantic search to see how they match. So that comes back. The first one, the top related things to magic spell are some of the lines in the book. Then for wand, it's kind of a one-word search, so you just see the times where it appears. And for the character names, you see what we have here in terms of, it's called overfitting within ML, where it's an exact match because the name is just being mentioned so many times, but then it's like not as interesting because maybe we want more varied responses. So that's when we can start to really play with that. And I will give you a nice example. Basically, if we look for the word brave, and we do a semantic search for it, we get back different results that have to do with it. Sometimes it's the word brave itself. Sometimes there's courage or bravery, so things that are close to it in that semantic space. If we want to add one of the other large language models, for example, sentiment, I take the negative sentiment associated with it, and all of a sudden we're looking at the opposites. So instead of brave, we have risked and fear and coward, and fear kind of comes up a lot. So again, because we can run hybrid search, we can introduce some filters. Say, I want to get a better picture of what the opposite of bravery is. So I can also say, please just exclude the word fear from there, so I get the other ones. And I still have fears, because again, it's like slightly different, but that was a very precise filter. So all of a sudden, it becomes risk and coward, mean and afraid, and all these kind of sentences that you wouldn't come up with in a different way. So using the different clients and putting them all together, you can do these pretty complex types of searches that help you go through your data in a very, new way. So to summarize, we've used the fact that Elastic is a vector database, so it allows you to store all those really big embeddings and dimensions. We've used different types of machine learning, like natural language processing, large language models when we get to the really big stuff, and then we have been able to create semantic search by putting those together. And all of that using these many, it's like 3 of them, Python clients, including also the name of the search, the embedding model that we use, just so we have even more acronyms up there. But hopefully this made a bit of sense of how we use these different clients, how we can do really cool stuff by combining everything together, and how, it's just cool because it's Harry Potter and it's magical. So, thank you.
It was an amazing talk. And I must say, you had a very difficult task because being the last speaker before the lunch break, like everyone I know, I see on your faces. I see a bit of hunger on some of your faces.
It's coming.
But still, your talk was so amazing that you see all those hungry people, they are still here. They were listening to you.
Thank you.
Okay, I already see the hands in the air. Okay, that's perfect.
2 hands. Seen one there, one over there.
Oh, amazing.
Hi, my question is slightly non-technical, but I want to get your thoughts on it.
Yeah.
So let's take the example of self-driving cars. So because humans don't like to give up autonomy, self-driving cars don't have to be safer. They have to probably be 100 times safer before we will accept them, basically. Similarly, for if I'm building an application, especially in slightly more sensitive fields, I don't know, financial services, where I'm using sentiment analysis, what sort of, firstly, are your views on it, but also capabilities that Eland allows to have some degree of explainability and backpropagation around why a certain result was reached?
Yes, great question. So indeed, if you want to be able to use a model within an exact field, first of all, a lot of them have regulations that would just not allow it, even if you can explain it in the most clear, non-black box way. Especially financial services, sometimes they say that's not okay. Because what if a model decides this person shouldn't get a loan over this other person? That's like really tricky stuff. So in some cases, I would say no matter how much you can explain it, it's probably not the best idea to have it there. Or you can use it in different phases that like summarize the data or collect it in an easier way for then a human agent to go through it. So rather than have it be the decision maker, it just makes it easier for people to make those ethical decisions. But then again, like as you mentioned, there are different softwares that allow you to see why a model made a certain prediction. There's things like attention that shows you like where in that sentence did the model focus on. And those also have results that show that it's a little silly. Like, for example, there was a model that could classify dogs versus huskies based on pictures. And once you use the attention algorithm, it showed that actually what it did is just look for snow in the background. And if there was snow in the background, it meant it's a husky because it's colder. So it was doing a completely random and unrelated thing. So it's quite hard to understand if the model makes sense. In Elastic specifically, at the moment, there isn't an implemented way to do that, but there are different open source projects that you could include in your pipeline. So there are ways to do it, but I would still say in certain situations, just don't do it. Hope that answered the question.
Hey, thank you. I have a few questions.
All right.
So I'm quite conversant with search, and I use other search engines. I haven't used Elastic. So the first one is, I saw that you were using like an exact match when you were searching, and the fears example. Does Elasticsearch support like a smart match or lemmatization?
Yes.
Or spelling, regardless of like region, British, American?
Yeah, so again, depending on how you do the mapping, you can define it as an exact field, which is called a keyword, or you can define it as just a text field. Then it takes into account a bit of more fuzziness around it. You can also change the processor you use when you put your data in, and you can define different lemmatization or different like ways to chop up your words or to store them. So there are a lot of built-in engines that you can choose from to decide how much leverage or how much like flexibility you want for your data. And then different types of search will have different results. So you can decide if you want it to be precise, if you want it to be like similar, or in the case with semantic search, if you wanted to even take that into account. So you can build it up as you want.
Okay. The next is the mappings.
Yep.
I saw that you were updating as you were going. In other search engines I've used, you have to define like a schema at the beginning. Is it, in Elasticsearch, is something you can update as you go?
So you define it in the beginning. That's also what I did. And if you want to change the mapping, you would have to reindex it, because then it's stored in different ways and it's expecting the results to be used differently. And like I said, depending on the type of field you have, you do different searches. But what you can do is you can also map a field as multiple things and then decide which one to use when you search. So you can say, the name of the person is both a keyword when you want the exact search, but it's also a text field when you want to look for something misspelled. So you do the mappings in the beginning, but hopefully you define it in a way that has room for growth, or you could change it later.
Okay, but when you change it, it changes, like, you have to re-index it. You have to do a new index.
Yes, I think there are cases in which you can update some of those settings, but it's like specific. I would have to know more about the case.
And the last one is for the semantic search. The embeddings, do you specify the dimensions? I wasn't sure if you did.
Depending on the model you use, they have their own number of dimensions. So I think the BERT one was like 500 something.
Okay.
Don't quote me on that. But then you can choose whichever model you want, and they would come with different dimension sizes. So you can use the really big ones from like Gemini that are huge, or you can use smaller ones. And then they kind of go with their own territory, or you can adjust that, but it's probably a feature in Hugging Face to choose the right amount of dimensions for it.
Okay, but you can specify on Elasticsearch?
Yes, and you can also do chunking. So you can decide like how to split your documents so that they match the right number of dimensions, or how to do your strategy for that.
Okay, thanks.
Sure.
Another question.
Hello.
Hi.
I'm what you call an amateur Python developer.
Awesome.
I'm actually in the middle of a career transition into the data industry. That's aside. Elasticsearch comes in a lot of job descriptions, and the ELK stack comes in there as well.
Yep.
So could you briefly explain in your own words what the ELK stack is and how to use it?
So ELK is ELK, is like Elasticsearch, Logstash, and Kibana, which are different tools within the Elastic ecosystem, so to say. So Elasticsearch is what I demoed today, the search part. Kibana is the dashboard. So the things in the beginning, like the dashboard I did and the discover where you could use syntax to search for words, that's Kibana. And it has different types of visualizations you can do. And Logstash is a way of importing data. So it has a lot of different connectors that allow you to make pipelines, like streaming data, migrating from a different data source and bringing stuff in. So together you can build like a whole solution of defining, take the data from here, do these processing to it, put it into Elastic in a search index, and then visualize it in Kibana. So that's kind of how that works. Sure.
Are there any more questions? Or are you that hungry?
We can chat while we eat. It's also fine.
Oh, that's
Let's do
probably
that.
the best way. So a huge round of applause. It was really amazing.
Thank you.